Very exciting today. A new mother function. I think. I don't know if we've talked about this one yet. I couldn't remember, to be honest, so I'm treating it like a new mother function. Do you guys want that blind closed, or is it pretty bright? You could just say something. So here we go, limit laws. Now, this is kind of a silly lesson, and you'll see why in one of my examples. But I still feel the need to teach it so that you understand where some of these come from. Though, again, we're dealing with the difference between concept and mechanics. And many of you know how to do the limits, but I'm going to show you the concept of where those limits come from. It'll make sense when I get there. So we're going to talk about the limit laws. What laws allow you to solve those limits? And for this point, we're doing plug and chug, algebraically manipulate, plug and chug, look at a graph, cry, pray, whatever. Plug and chug again. Yeah, okay, yeah, yeah. We do have one new theorem called the squeeze theorem. It's exciting. Also known as the sandwich theorem, also known as the pinching theorem. I like the sandwich theorem. You'll see why in a second. And then, hey, this weekend, let's try to relax, okay? You got 3 days off. Put your schoolwork away for a little while. Get outside, play in traffic.
Plane traffic.
New mother function! Have we seen this one before yet?
No.
All right, maybe it's not new. Sorry.
Nice.
Absolute value of x over x. Okay, Luke, take your hat off. Thank you. Okay, forget about the limit part, just the absolute value of x over x. If I would have just given you the function without a graphing calculator or decimals or anything, you could have come up with the graph. It's not that difficult. Put in any number. You just give me number 1 through a billion. 3. Wow, okay, get crazy. I gave you a large number of choices and you went with 3. 42. You're changing. 42. The absolute value of 42 is 42. Over 42 is 1. Whoa. Give me a number between negative a billion and 0. Negative 39, what's the absolute value of negative 39? Over negative 39 is? There you go. See how that works? Any problems? Now, it would be nice if it was that simple. Sometimes it won't always be that simple. Like they're going to do something saucy. Like, throw in this. What's that look like? That's the same function, just move it 6 to the right. Okay? What about this? What, the absolute value is on the bottom, doesn't matter? No, it's all the same thing. Okay, so most of the applications, just like when we look at something like the square root of x, and then we do all these transformations, we can do all those transformations with this new mother function. Notice, undefined at 0, those are open circles. Muy importante. Okay? So, introducing the new mother function, refreshing your memory on right-hand limit matching left-hand limit. Okay. At 0, it is undefined. Everywhere else, there's a limit. And that limit, which, again, you probably figured out, is either 1 or negative 1. No other options. It's fun, right? Right. All right, I'm going to go through these quickly because they are fairly logical. What's the limit of some number b when x approaches c? Well, that's the silliest thing ever. What's the limit of 2 as x approaches 12? It's 2. Think about the graph. What's the graph of 2 look like? All lines are straight. horizontal line. So no matter what value you pick for C, you get that, okay? It's a horizontal line. Beautiful. What's the graph of y equals x look like? Does everybody get it? Nothing. 45-degree angle. Every point on that line has the same a and b value, same x and y value. So you plug in 2, you're going to get out 2. You plug in negative gabillion, you get negative gabillion. And then 3 is just the exponential rule. It's the same thing as a plug-and-chug. Now I'm going to go through this quickly. You don't need to write it down. Just be mathematical sponges and absorb information. Put your pens down for a second. You already have it in the slideshow, but just watch. The limit of a sum is the sum of the limits. The difference of the limit of a difference is the difference of the limits. The limit of a constant versus a function is equal to the constant times the limit. Those are fairly logical. More of them. Oh, the limit of a product is the product of the limits. The limit of a quotient is the quotient of the limits. Just like you did with a lot of other things in the mathematical world. It makes perfect sense. So, if we're doing something like this, following the limit laws, the first thing you would do is split that into 2 different limits because the limit of a sum is the sum of the limits. Then, the first one, you bring that 4 out in front because the limit of a constant times a function is the constant times the limit of the function. Then you'd apply one of the other rules. The limit of 3 when x approaches 2, that's the horizontal line thing. Boom, you get 3. And then the limit of x squared is the exponential thing. That is absolutely absurd. You're never going to solve a limit that way. What are you going to do? Anyone? Plug and chug. However, these laws are what allow you to plug and chug. Okay, so we're going to find that whenever possible, plugging and chugging. We're not going to split up into a whole bunch of limits. It's too much time. Too silly. All right, try this one. I'll wait. By the way, the answer is not DNE. 8 body volume.
Zero in the positive direction.
No, you should be positive.
It's zero. Yeah, it is zero.
I agree with you. Yeah.
It's zero. Right?
I was going to say that. I was literally going to say that. I said there is a way.
Shit like that, all good. Yeah. The markers.
Click on the pen at the bottom. What color do you want? Red? There you go. Go crazy. These are my original arms. I haven't had them replaced. This one about 5 years ago. I didn't want to be off. No, he's going to say just mirror images of each other. Oh boy. Oh boy. It was 2-0. Catholic school, public. Alrighty. So, walking around the room, I saw that all of you plugged and chugged, yes? And got 0 over 0. So many of you then stopped and said D and E. What are the rules? Plug and chug, algebraically manipulate. As you can see, you can multiply that out. 3 plus k quantity squared is 9 plus 6k plus k squared. Not 9 plus k squared. I'm going to throw an extra step in there, just because I want to make sure we didn't lose anybody. There's a lot of crossing out going on here, which gets to be a little sloppy math. I'm on board with the 9s canceling, but then we get to 6k plus k squared over k. And again, remembering to write the limit every time. What I would prefer to see is the following. Then cancel. Then plug and chug again. Now, why? Why am I making a big distinction between what I did in blue and what Andrew did in red? I have found that students get sloppy when they try to cancel all those things at the same time. You might miss a term that has a k in it. You might cancel something that isn't supposed to be canceled. You might forget, let's say that k was cubed. You might forget to change the k cubed into a k squared. So I want you to factor out the variable first so that you have just that cancellation. Now, we could have broken down this whole limit using the limit laws. Turn the quotient into the limit of two quotients, and then do the minus and the squared and all that other fun gunk. But realistically speaking, you plug and chug first, you algebraically manipulate, you plug and chug again. If that second plug and chug doesn't work, that's the point when you say, yep, doesn't have a limit. If you got a calculator handy, you can also graph it and see if that works. Questions? Hot diggity. Moving on. We talked about number 1 already. Looked at the graph, saw what that looks like, came to the agreement that it's equal to 1. The other one, you can either trust me on or you can graph it. It's not easy to solve algebraically. You will hear me use the phrase flashcard worthy. Unfortunately, as much as I hate memorization, there are some things you're going to have to memorize. This would be one of them. It's not an extremely common thing to pop up, but it does show up every once in a while. Good? Okay, how about this guy? What do you do first? Plug and chug, what's the tangent of 0? 0. What's the denominator? 0. 0 over 0. Now we start to cry. Or, no, I'm out of order. Algebraically manipulate first. Crying comes later. How do I algebraically manipulate that function? Let's convert to sine x over cosine x and see what kind of fun happens. Limit as x approaches 0. Again, writing the limit every time. Sine x over cosine x over x. Don't get sloppy. By don't get sloppy, I mean write the limit every time. Write the sine of x. Just writing the sine doesn't mean anything mathematically. Sine of x, cosine x. Dividing by something is the same thing as multiplying by its reciprocal. Then I'm going to get all fancies in my pantsies. I'm going to pair those two up together and turn this into two different problems. So this is going to become the limit as x approaches 0 of the sine of x over x times the limit as x approaches 0 of 1 over the cosine of x. Because the limit of a product is the product of the limits. We know what the sine of x over x is. We have that right there. It's equal to 1. Bam! What's the limit as x approaches 0 of 1 over the cosine of x? What's cosine of 0? 1. And therefore we get a final answer of 1. Not so bad. Here we go. This will be fun. We're going to approach this two different ways. One is the concept, the other is the application. In this case, I think the concept's a lot easier. The application gets a little nasty. There's a reason why I call it the sandwich theorem. Let's suppose you're making a lunch meat sandwich. Anybody eat lunch meat? Yeah? That's what we're doing. Salami. So we're going to make a salami sandwich, right? You take your two pieces of bread. You put your salami between the two pieces of bread. You eat your sandwich, right? At any point in time, does the salami come flying past the bread out of the sandwich? No, it doesn't. I don't know how you eat your sandwiches, but for the average human being, the salami stays between the two pieces of bread. Now, you might mash down your bread a little bit, or you might throw some potato chips on that sandwich. No, anybody? Potato chips on the sandwich? Yeah.
I don't know why we just this
What else would you like on the sandwich?
cheese.
You can put cheese on there if you like, sure. Put cheese, anything else?
I love to throw some ham on there.
Ham salami.
Ham, salami, cheese, anything else?
No, that's not.
That's it? Okay, beautiful. All right, so we're making a ham, salami, and cheese sandwich. That sandwich requires two pieces of bread. Once he makes that sandwich, the bread, the essence of a sandwich is that it is the essence of a sandwich is that we have something sandwiched between two pieces of bread. Done? Good. At no point during that sandwich experience do things come flying out of the sandwich. They don't just pass through the bread and fly away. Why does this matter? Because this is how the squeeze theorem works. I have three functions there, h, g, and f. And the thing to note is that h is always bigger than g, and f is always less than g. In other words, g is always between those other two functions. So for our purposes, h and f are pieces of bread, and g is all the lunch meat, whether it's ham, salami, or cheese. G must stay between h and f. As soon as it flies out of there, the squeeze theorem no longer applies. Okay, so you with me? And notice, you're squeezing it down to a point. So I don't know about you, but when I was a kid, I used to eat the crust off my sandwich and then press the sandwich down and fold it over. Anybody? Okay, I guess I'm the only freak in the room then. Fine. Don't shake your head yes, Max. Okay. How does this apply to us? Well, if G stays between F and H, and we know what value F and H approach, G has to approach the same number. If I smash the bread down to a certain point, salami, ham, and cheese are going to stay between the bread. And we can use that to find the limit of the lunch meat. For some reason, I don't know how to find the limit of the lunch meat, but I can find the limit of the breads. That's easy peasy. Before I move on, does that make any sense whatsoever? Are we okay with the concept? See Victoria shaking her head. That's enough for me. I'm moving on. Thank you. I'm glad you're here. Okay. So here's the function. Now, if I said to you, find that limit, you might panic a little bit, because when you plug and chug, you get a mess. So, we're going to build our sandwich. And this is where things get a little bit ugly. I would argue that the squeeze theorem / sandwich theorem / pinching theorem is the reverse of a lot of things we do. I think a lot of things we do, the concept is more difficult than the application. This is the opposite. I think the concept makes more sense. The application is a little bit different. Okay. By the way, that's what the graph looks like. It's what's called a dampening function. If I zoom in, it looks just like that. If I zoom in again, it looks just like that. No matter how much I zoom in, it always looks like that picture. Okay. So how do I build my function? And you can see, if you look at the picture for a little bit, you can already understand what's going on. This is the graph of that function. Here are my pieces of bread. And if you look at it carefully, it actually turns out that the pieces of bread are just x squared and negative x squared. Okay, but we got to get to that point. So the construction of the sandwich goes something like this. Let me explain this. You all know the fact that if I take the sign of anything, it's always going to give me a number between 1 and -1. You know that, yes? Good. There's a reason why I called the first one the sign of t, because I'm going to get rid of t and I'm going to put something else in there. It doesn't matter what I take the sign of. It can only give me an answer between 1 and -1. So if I take the sign of x, I get between 1 and -1. I take the sign of smiley face, I'll get between 1 and -1. So I replace the t with a 1 over x squared. Well, why a 1 over x squared? Because that's what I need for the function. I stuck that in there. That still has to be between 1 and -1. I'm taking the sign of some function. Third step, all I did is multiply everything by x squared. Why by x squared? Because there's an x squared out in front of the function. And that is what we needed. What does that tell me? That tells me that my lunch meat is making a sandwich with 2 pieces of bread, and the pieces of bread happen to be the x squared function and the negative x squared function. And it establishes that the function is always between the 2 pieces of bread. So the way the sandwich theorem works then, or the squeeze theorem, it now says, now that I've established this, in order to find that monstrosity, all I have to do is instead find the 2 limits of the pieces of bread. What's the limit of negative x squared? What's the limit of x squared? They both approach 0, so therefore the problem approaches 0. Now the graph is kind of an easy giveaway. If you look at that graph, you could have all told me that the answer is 0. That's why I think the mechanics are more difficult. Building that sandwich with those functions can be a little bit difficult. Almost exclusively, squeeze theorem problems involve some type of trig. I'm not sure why. Maybe because it's too difficult to create a dampening function without trig. You build your sandwich, you take the limit of the pieces of bread. If they're the same number, then you're good to go. And that tells you the limit of the ham, salami, and cheese. Good? Questions? We're all done. You will see some some repetition on the problems tonight, that's okay, it's good practice. We'll get into some newer stuff on, when will I see you again? Today's Friday? Wednesday, right?